Hi, I'm Hideki Joko from Radobari University. In this presentation, I would like to introduce our research, personal entity, concept, and named entity linking in conversations. What is entity linking? Entity linking is the task of recognizing entity mentioned in the text and identifying their corresponding entities in knowledge graph, such as Wikipedia. In conversations, as well as the importance of named entities, concepts play an important role. Additionally, understanding the personal entities, in this example, my cars, is also important. These personal entities are usually referred by pronouns such as my and our. So why entity linking in conversation? Entity linking enables connecting natural language and external knowledge, and because of that, it is also known as effective for question answering and retrieval tasks. But why not simply use traditional entity linking approaches? There are three main challenges. Traditional entity linking approaches are mainly for documents or short queries, and they do not link personal entities, which are more frequent in conversations. Also, their main focus is on named entities, and the concepts are usually not paid much attention to. Training data is also a challenge because existing approaches are mainly trained on well-written text, and training data for entity linking in conversations is limited. Our contributions are twofold. We provide an open source entity linking tool for conversations, which identifies personal entities, concepts, and named entities. Also, we provide a dataset for training and evaluating entity linking in conversations. Let's start with entity linking for conversations. In this slide, I will explain the personal entity linking pipeline of our tool. First, detect mentions and perform entity linking for concepts and named entities. Then, detect personal entity mentions, in this example, my cars. And finally, link personal entity mentions, my cars, to the detected entities in the history of the user utterances, in this case, on the life. For personal entity mention detection, we use a pattern matching approach. More specifically, spans starting with my and our, followed by adjectives, nouns, and or numbers are detected as personal entity mentions. We also validated this simple yet effective method in our paper, so please check it if you're interested in. Given the similarity between coreference resolution and personal entity linking, we utilize the coreference resolution technique to link personal entity mentions to entities. In the next slide, I will explain more details on how to perform this linking. We calculate the compatibility scores, which are used to find the link of personal entity mentions. This score is computed by the combination of start and end token representations of antecedents and anaphora. Look at the example. First, we take the start token of the mention and calculate the start token representation MS. In our setting, this token representation MS is calculated using transformer token representation. Using this token representation, we calculate the compatibility score. Again, the compatibility score is computed by the combination of start and tokens and antecedents NAFRA. Here, NAFRA is the current mention in this example by cars, and antecedents are the mentions appears before a NAFRA. In this example, all combinations are like So let's go back to the personal entity linking pipeline. For concept and named entity linking, we fine-tune BORT and write about entity linker CREL on our dataset. BORT is used for mention detection and CREL is used for entity disambiguation. For more details, please refer to the paper. So let's move to the explanation about our dataset CREL2. Our entity annotations are created on the existing conversational dataset. Following our previous work, we select Wizard of Wikipedia for the dataset. Then we ask crowd workers to annotate personal entities, concepts, and named entities. Our dataset includes approximately 1,300 utterances with entity annotations. For more details about dataset selection process and annotation process, please refer to our previous paper. Experimental setup. For the personal entity linking, the proposed method utilizes S2eqref, which is the state-of-the-art coreference resolution method. For the baseline, we use Wikipedia 2vec best method. Following Joko et al., we use Wikipedia 2vec cosine similarity between the entity and personal entity mention. For concept and named entity linking, our proposed method CREL is trained on our CONEL2 dataset. For baselines, we use rel, genre, tagme, and what. For the dataset, we use our dataset CONEL2 for both training and test, and CONEL-PE only for the test purpose. The table shows the overall results. AL column represents what entity linking method is used for concept and named entity linking. PE column represents what PE linking method is used. From the results, it is found that our personal entity linking method is more effective than baseline Wikipedia 2vec based method. Additionally, our entity linking tool, which is trained on our CONEL2 dataset, improves the effectiveness even when compared to the best performed baseline. This suggests the importance of training the model on the right data for entity linking in conversations. Conclusions. In this research, we provide two resources: CREL, open source entity linking tool for conversations, and CONEL2 dataset, which can be used for training and evaluating the entity linking in conversations.